Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're introducing standard form and converting ordinary numbers to standard form. So, previously on Hegarty Maths and on the last video on powers of 10, I asked you to convert the following into ordinary form, i.e. write the following multiplications as an ordinary number. So pause the video and double check you can still do that. And here are the answers as follows. Now in the last video actually showed you how to get these answers, and I'll show you for two examples. Say this one here. I said 10 to the power of 5 was 100,000, right? And I said you've got two lots of 100,000, which is 200,000. And in a case like this, say 10 to the power of negative 3, well 10 to the power of negative 3 is 1,000th, and so you've got 5 lots of 1,000th, you've got 5,000ths. Now these numbers here are what's called ordinary numbers. They're what we're used of in maths. We usually deal with ordinary numbers written in their normal form. But these numbers actually have a special name. They're called numbers in standard form or standard index form. So sometimes it's even called standard index form. And what we're going to learn about in this video is what is standard form and why would we want to write in standard form, and how to convert our numbers from ordinary numbers into standard form. So let's go on and take a look at what standard form's about. So imagine you had this number here, which is 2 billion. Mathematicians, as we talked about in the past, always like finding quick ways of writing something, and they can't be bothered to write all the zeros there after the 2. So what they say to themselves are, well, 2 is an important number, it's a non-zero number, and they say, well, we need to write that down, but rather than writing 2 with 9 zeros after it, I'm going to say that's like 2 billions. And I know billion in power of 10 is 10 to the power of 9. So I can write this as 2 lots of, or 2 multiplied by, 10 to the power of 9. Similarly, with small numbers, they would say, oh, I can't be bothered to write 2 billionths with 9 zeros in front of the 2. So let me write down the 2 by all means, but I know that a billionth, the way I can write that is 10 to the power of negative 9, and that is a much easier way for them to write it. Now in particular, you may think that's not that easy. When you're dealing with numbers involving planets, etc., then the amount of zeros after the number could be huge amounts, and this is therefore going to be way quicker than writing a 2 and maybe 13 or 14 zeros after it. And similarly, when you're dealing with tiny little things like blood cells, the amount of zeros before a digit might be a massive number, so it's much better to write it in what's called standard form. And so, to summarize, a number is said to be in standard form or standard index form if it's written in the following way. It's got a number here, and it's multiplied by 10 to the power of something. And it's really important what a is and what n is. A is a number that can be 1, but must be less than 10, absolutely must be less than 10, and I'll explain that a little bit in a second. And n, well, n is 9 or negative 9. N is what's called an integer. N must be an integer, and that means a whole number, which can be positive or negative. It's positive for big numbers, it's negative for small little numbers. Now, just before we move on, why does a have to be less than 10? Well, let me explain. Someone could say this is the same thing as, let's say, 20 times 10 to the power of 8. They could certainly say that if they decided to have the first number a to be 20. Alright? Now, if mathematicians all over the world decided, well, I'm going to use a between 1 and 10, and someone else said, well, I'm just going to make sure my a is between 1 and 100, etc., then it wouldn't be standard form, would it? Everyone across the world will be writing their numbers in different ways. So mathematicians have agreed always have the first number between 1 and 10, and that way, if everyone across the world is using it that way, we can compare and understand our numbers, and hence the word standard index form. So it's really important, and we're going to see this later on, that that first number here is between 1 and 10, and n is a whole number. Right, I want to show you how to go from an ordinary number to a standard form number. Now say you had 7,000. One way of doing it is to say break it up into 7 lots of 1,000. I know 1,000 in power form is 10 to the 3, so this must be 7 multiplied by 10 to the power of 3. But there's a quicker way. Let me show you the quicker way. The first non-zero number is the 7. if I write the 7 down like that, then what I do is if I count how many digits after that, there's 3. And so because it's a positive number, I say it's multiplied by 10 to the power of positive 3. And that always gets me a really quick way of working these out. In particular, can you imagine when the zeros are massive there? It's going to be long to do it this way here. Well, it'd be much quicker to do it the shorter way. So let's give it a go with this number. I look at the first non-zero number, which is a 2. I write it down. I count how many digits after the 2. 1, 2, 3, 4, 5, 6, 7, 8. Because it's a big number, times 10 to the power of positive 8. And we're done. Now, in small number cases, you do the exact same thing. You find the first non-zero number, which is 5. You write it down. Now, because we've got a small number, we count how many digits before the 5. There are 3. Now, we're not going to say times 10 to the 3, are we? Because they're for big numbers, like this. We're going to say times 10 to the negative 3. And it's a really quick way of actually writing these in standard form. So this one here, I find the non-zero number, the first one, 7. I count how many digits in front of the 7. 1, 2, 3, 4, 5, 6. That's multiplied by 10 to the negative 6 because it's a small number. And that's a really fast way of going from ordinary to standard form. So let's use that to do some questions. Pause the video and have a go yourself. Right, I'm going to write this as 6 multiplied by 10 to the 1, 2, 3, 4, 5, 10 to the power of positive 5 because it's a big number. This next one, I'm going to write down my 3 times 10 to the, count how many after the 3, 1, 2, 3, 4, 5, 6, 7, to the power of positive 7. This one here, now I can't write 10, okay, it's really important, remember the number's got to be smaller than 10. I'm going to write 1, the first non-zero digit, and count 1, 2, 3, 4, 5, 6, 7, times 10 to the positive 7, and there you go. Now what about in this case here? These numbers are very like this number. They've all got a 6, a 3 and a 1, just like the one to the left, but they've got another digit after them, or 2 digits after them. So what I'm going to do is I'm going to write down 6 and 3, the first 2 non-zero digits. Now, I can't have that number, remember, being bigger than 10, so I'm going to put my decimal point there. And I'm going to say it's times 10 to the power of, do the exact same thing, count how many digits after the 6, it is 5. What about this one? I'm going to write down my 3 and my 7, going to put a decimal point between them because this first number has to be less than 10, times 10 to the power of 7. Exactly the same thing here, write down the 1, the 4 and the 5. Where does the decimal go? Well, it must go here, and you count how many digits after the 1, so it's times 10 to the power of positive 7 because it's a big number. Let's do the same thing with small numbers. Pause the video and have a go. Right, the first thing I do here is I write down 6, the first non-zero number, times 10 to the power of, I count how many digits before the 6, 1, 2, 3, 4, 5. I can't put 5 because it's a small number, I put negative 5. The exact same here, write down the 3, 3 times 10 to the, count how many digits before the 3, 1, 2, 3, 4, 5, 6, 7, therefore to the negative 7. This one here, 7 times 10 to the, 1, 2, 3, 4, 5, 6, negative 6, and there we go. These are similar, but after the 6, the 3 and the 7, there's another digit or more digits. We do exactly what we did in the big case. We write down the 6 and the 7, the decimal point must go there because the number's got to be between 1 and 10, times 10 to the, and we just count 1, 2, 3, 4, 5, 5 digits before, so it's to the negative 5. And similarly for this will be 3.9 times 10 to the negative 7. And similarly here we write the 7389 times 10 to the, now we must put the decimal there, don't forget, because that number's got to be between 1 and 10, 1, 2, 3, 4, 5, 6 to the power of negative 6, and we're done. Now, Avogadro's number is an important number in chemistry. See if you can write that in standard form. Pause the video and have a go. So what I do is I write all the digits down until the zeros start, so 6, 0, 2, 3. Where do I put my decimal point? It has to go here because that number's got to be between 1 and 10, times 10 to the power of, now I count how many digits after the first one, 1, 2, 5, 8, 11, 14, 17, 20 and 23. There you go, Avogadro's number in standard form. And the last one, a small number, a hydrogen atom has a mass equal to that, write it in standard form. Pause and have a go. I'm going to write down the 1, 6 and 7. Where do I put my decimal point? After the 1, times 10 to the power of. Now I have to count how many digits before the 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 to the power of negative 24 because it's a small number, and that's it, we're done. So that's it for converting ordinary numbers to standard form. Thanks for watching.